All right, when I recorded the Section 2, Unit 9 review earlier, or Secondary 2, excuse me, I didn't have the sound on, so got the sound on this time. We'll try it again and see if this one works any better. Okay, so for this function, we're going to graph it and then fill in any accompanying questions. On the test, you're not going to have a problem like number 1. It's a little bit tricky, but let's go ahead and see what we can do with it anyway. On your 9.3 notes, you have a list of all of the functions. And this one fits the category of an exponential function because one way to see that is that the variable is in the exponent. Notice you have domain and range here, and our domain and range is going to fit this one as well. So I'm going to just kind of toggle back and forth between these two. So it will have a domain from -infinity to infinity, and its range, since nothing is telling us to shift up or down, its range is also going to be from 0 to infinity. Now we do have a shift right here that's inside the function adding 3, so that's telling us to go left 3. And so our parent function, notice, has a point at 0, 1, and at 1, 2, and at 2, 4, and then it's getting smaller over on this side. So I'm going to replicate that, except we're moving it, right? We're shifting everything to the left 3 is what we said. So we're going to have a point here, there, it's at 1/2 there, this one's up to 4. We could also find these by plugging in values into the equation and seeing what we get out of it, but I don't want to spend the time on that since this one is quite quickly done. The other thing is we said the parent function is e to the x. Since e is a value, a number that's just a little bit greater than 2, this one would actually probably be a compression because it's slightly smaller. But I've told you that everything greater than 1 is a stretch, so I'm not going to write either of them there. I can't write the wrong thing, and I don't want to write the other thing because it's counterintuitive. So anyway, kind of ignore problem 1, but there's some hints to go with it. Okay, looking at number 2. This is an absolute value function. You can tell because of these two lines right here. And you might remember or see from that picture that the absolute value function has this like V shape, like this. Now this one is telling us to shift to the right 2, down 1, and reflect. Okay, so I'm going to go ahead and put that down here where it's asking for transformations. So it's saying reflect over the x-axis. I should probably have a hard copy right here with me so I can see this. Down, let me grab that paper. Sorry, down 1 and right 2. Okay, I've got it over here with me so I can see it. Okay. So we're taking the parent function, we're going right 2, down 1. That's going to be our vertex, and it actually asks for the vertex down here. So let's put that in 2, -1. And then this is telling us to reflect it, so it's going to open down. And the slope is just 1 still, down like that, right? So it fits that look. Okay, domain, this is as we look left to right. We will always have the function happening, right? There's an arrow going this way, an arrow going this way, so forever left and right we have stuff. So domain is -infinity to infinity. The range is low to high. On the low part we have function things happening down here, right? But it stops when we get to that point at -1. So we're going to say that our range is from -infinity until -1. It's increasing until we get to the yellow line and then doing the opposite on the other side. So we're going to look from left to right, and as I look on this left side, you can see that the function is going from low to high, so it's increasing on the left. So we're going to say it's increasing from -infinity until I get to 2. Then when I continue right after 2, you can see that the function is going down. So after 2 until infinity, it's decreasing, or to infinity. Okay, roots. Roots are x-intercepts, And notice that this is not going to touch the x-axis anywhere. So the answer here is none. No roots. And then this is asking about end behavior. We have all this notation together. So this first line is saying, when you look to the left, where is the function going? So as you go way far out to the left and look at the function, it's going way down. So it's headed to negative infinity. And it's actually doing that on this function if we look to the right or to the left. In both cases, it's going down to negative infinity. All right, based on what we did on number 2, you should be able to have quite some good, easy success with problem 3. So hopefully you can identify the vertex from what's given there. It's saying left 1, down 1, up 1, excuse me. So let's plot that point, left 1, up 1. Now the a value is 2, so that's telling us to rise 2, run 1. And then we also want to do the run in the opposite direction. There's our graph. We want to mention our transformation of 2 as well, so we're going to say stretch by a factor of 2. Okay, domain and range. This is pretty straightforward. Domain is everything again, left to right. Low to high, nothing starts until right there. So the range is from 2 to infinity. It's increasing from -1 to the right. So we're going to say increasing from -1 to infinity and decreasing from negative infinity to -1. Roots, again, not touching the x-axis, so we have none here. End behavior, in both cases, looking left or right. This one's saying look right. It's going up, so to positive infinity. Okay, let's take a look at this one. We're going to compare each function with f of x equals absolute value of x. So there's the parent function that I'm highlighting in green. What we're going to do is look at the function that we've been given, this one that I'm putting in yellow, and we're looking for all the ways that it's different. So there's this 1/2 that makes it different, a +7 inside of there, a -10. Okay, the notes page that's super handy for this is this one right here. We described in detail what each of the parts are doing, right? So if you add inside of the function, it's telling you to go left. If you subtract inside of the function, it's telling you to go right. If you multiply the function by a negative, it's telling you to reflect, right? So we're paying attention to all of those things. This is a good note page to have as you're looking at it. So this one is telling us the 1/2 is saying compress by a factor of 1/2. This +7 inside the function is saying left 7. And the -10 outside is telling us to shift down 10. Okay, on this one there are 4 things. The negative, the 3, -6, +9. So the negative is saying to reflect across the x-axis. The 3 is telling us to stretch by a factor of 3, vertical stretch by a factor of 3. X -6 inside is saying right 6. And then the +9 at the outside is up 9. Number 6, we have a negative, 1/4, -1, +4. The negative out front is a reflect. The 1/4, since that's between 0 and 1, right, we're talking absolute value there, between 0 and 1, this is a, compression by 1/4, by a factor of 1/4. X -1 inside the absolute value is telling us to go right 1, and then outside the absolute value we have a +4 that's saying up 4. All right. Number 7, 8, and 9, they want you to identify the parent function and describe all the transformations. Okay, so we have a couple things doing here. Now, to identify the parent function, I think it's worth taking a look at this, right, and looking at each function, seeing which one this fits with, and I think it's going to be reciprocal because we have a variable on the denominator. All right, so we're going to write what function it is, and I'm just going to write the equation of the parent function like this. You could also write the word reciprocal, or instead write the word reciprocal, that's fine. Then I'm going to use that and identify all the things that are different than the parent function. Okay, so that negative in front is telling me to reflect across the x-axis. The plus 4 here that's right by the x, so that's like it's inside the function, that's telling us left 4. We have a minus 3 out here, so that's down 3. And then the 6 could be confusing, but I want you to know that 6 times 1 over x can be written as 6 over x. So it is our a value. It's the thing that we're multiplying by. So this is a stretch by a factor of 6. All right, number 8. I recommend that you pause here for a second, take a look at your notes page, and identify which parent function this comes from. Okay, you might have noticed that it is the square root function. The things that are different here are these 3 things. So the 3 out front is a stretch by a factor of 3, vertical stretch. The minus 2 is under the radical symbol, so that's part of being inside the function. So that's telling us to go right or left. If it's minus something, it's right, which is counterintuitive. If it's plus something, it's left. And then the thing outside, plus 1, outside of the function, right, out at the very back, this is telling us to go up 1. That one would say up or down out there. Okay, number 9. Take a minute, look at your function page, and see if you can identify the parent function here. In this case, the parent function is x to the 3rd power. All the things that are different are these. So that negative is telling us to reflect. The plus 1 inside is telling us to go left 1. The minus 1 outside the function is telling us to go down 1. All right, besides number 1, which was quite tricky, hopefully you're able to have success with all the other problems on here. These are the sorts of things you'll see on the test. Let's try the second page. For this problem, they want us to write the function for the graph. So again, this note page is quite handy because we can look at the pictures here and see which picture is most like what we've got going on there. And it's this one, right? It's our absolute value, this V-shaped graph. So here we have a V-shape. The parent function looks like this. So we're going to pay attention to how it's being shifted and then write that in as part of our equation. The parent function did start at 0, 0, but look, this one is being shifted right 2 and down 4. So those are things I want to put into my equation. So to say to go to the right 2, and this page is handy for this sort of stuff, right? To go right, we can look at what it's talking about there. So right 2, we're going to go inside of the function and say x minus 2. And then we also went down 4, so we're saying minus 4. Let's take a quick look at our slope. Notice that on the right it's headed up, okay, and it's going rise 1, run 1. So I'm just going to leave that as it is. Don't even need to write anything in there. Okay, let's try number 8. It's a parent function, but it has been shifted to the right and down, and it's opening down. Okay, so we need to make sure that those 3 things are mentioned in our equation, right? So we'll have f of x equals, to open down, it's going to be a negative. To go to the right 2, I'm going to put minus 2 inside of the function. And then to go down 2, we've got minus 2 outside of it. Okay, number 9. This one's opening down as well. So I could say negative out front of the absolute value. Oh, we should have checked the slope. Did we already? That's just a 1 by 1 by 1, so no change there. This one also, rise 1, run 1, right? So no change there either. This one's being shifted left 4, up 2. So to say left 4, we're going to go x plus 4. Up 2 is going to be plus 2. Okay, hopefully that part goes well. Okay, number 10, write the function, excuse me, that describes the translation. So what they've done here is given us one function, sorry, highlight it, this function, which is being shifted to the right 6 up 2, and they're saying take that function and translate it 1 unit up. So we want to go, it was up 2 already, we want to go up another one. And it was already 6 to the right, we want to go 4 more to the right. So all together with these shifts, it's going to look like x minus 10, because like I say, it was going to the right 6. We said go 4 more to the right, so now this is right 10. Was going up 2, we're going up another one, so we have up 3. Okay, number 11. This one's saying 3 units down, so we're going to subtract 3. 3 units left, we're going to add 3 in there. So our new function looks like x plus 5 minus 8. Okay, 12 and 13 are kind of wordy, but actually quite easy. Essentially what they're saying is you have two functions here. They're almost identical, except g has been multiplied by something. So because of that multiplication there, is this a stretch or compress? And since 3 is greater than 1, this is stretch. That's all we need. On 13, the only difference here, multiplied by 1/3. Since 1/3 is between 0 and 1, this is compress. We could say compress by a factor of 1/3, that would be fine. The instructions on this part said tell whether the graph is a vertical stretch or a vertical compression. So we've said stretch or compress. It wasn't asking for the factor here. However, I want to draw your attention to the fact that over here, when we were listing the transformations, and I said this was a stretch, I said by how much? Okay, stretch by a factor of 2. I do expect that on the test. So if you're not sure whether you have to say the factor or not, it may be worth just saying it, just to be on the safe side. If you can see whether it's asking for it or not, then you can be more discerning. But if you're not sure, just go for it and write it. Okay, 14, 15, and 16. Graph the following functions and describe their transformations. Okay, on number 14, we haven't really in class graphed any of these, but this is a square root function. So let's look closely at what the square root function looks like graph-wise. You've got a point at 0, 0, 1, 1, and then 4, 2. Okay, our equation had the square root of x minus 3, so that would be telling us to shift to the right 3. 1, 2, 3. So let's see, 1, 2, 3. So our new graph is going to look something like that. Okay, so 3, 0, 4, 1. I'll try and remember that as I head back over here. 3, 0, 4, 1, and then we had something out there. Okay, that's what our new graph is. And graph the function and describe their transformations. And this one is pretty straightforward. It's just right 3. If you're not comfortable making the transformation based on the picture that we saw before, you could plot some points, okay? So if I plug in the value like 0, 3, 4, I'll pick those 3. If I plug in 0 for x, then I'd have square root of 0 minus 3, which is square root of negative 3, which is I root 3, which is not a real number, so it's not going to show up on my real graph. So this one we have a sort of, it's not part of our solution set. It doesn't show up on this graph. If I plug in 3, I'd get square root of 3 minus 3, which is equal to the square root of 0, which is 0. I shouldn't have put 3 there, should I? I put a 0. So that's telling us that for the graph, I go to the right 3 and then 0. Yep, we've got that point on here. If I plug in 4, square root of 4 minus 3, that's square root of 1. 4 minus 3 is 1. And the square root of 1 is just 1. So the point 4, 1 should be on my graph. Okay? Whichever way you like to do it. When I was a student, plotting points was how I graphed stuff, because it was hard for me to remember and conceptualize the other parts of it. But if you can do that, you're certainly welcome to do that as well. Okay, number 15, identify the parent function. This is absolute value. It's being shifted right 2, down 1, and reflected, opening down. Reflected about the x-axis. Okay, so right 2, down 1, there's my vertex, and then, excuse me, it's opening down, and its slope is just, right, the 1, 1, 1, 1, so we got it. All right, number 16, we want to identify the parent function. So take a second and do that if you haven't already, maybe looking at your note page to see which one this is. It's the cube root function. So notice that we have something at 0, 0, 1, 1, negative 1, negative 1. Because this function has the third root of x plus 3 minus 1, that's telling us to shift left 3, 1, 2, 3, and down 1. So I can essentially move each of these in that direction. 1, 2, 3, down 1. This one is going to go 1, 2, 3, down 1. Okay, these 3 that I'm going to highlight in green are the new points that we know we've got. Okay, so it's going to be kind of a curvy thing like that. Let's see. Yeah. And that sort of flattens out. And this one curves to that and then flattens out. Whoops. Maybe flattens out on its way down just a little bit. Okay, graph isn't perfect, it doesn't have to be, but we've got some definite points in there that we've drawn attention to. Right, and then we have, it's holding the general shape of what the other picture was doing. All right, so that's what I need to put on the grid. So I'm going left 3, down 1, and then we've got, whoops, points all around it. Here we go. Left 3, down 1, so that's on there, that's on there, that's on there, and it's got sort of a curving like that, and then it's just kind of shooting out like those. Okay, let's talk about these transformations. We have left 3, down 1. All right, I will provide you with some notes tomorrow, okay, so you will get a blank page like this. You'll get one like this. I'll have filled in the information. And those should be sufficient for you to have success. I might include some other things that might help you out too. So you definitely have these 2 things to use tomorrow. I'm going to provide you with a new piece of paper with these notes, because if I have you bring what you've already got, you might have other notes on there, and I want to limit it to everybody having the same thing that I'm providing. So that's what it will be tomorrow. You may also want to bring a book in case you finish before class is out. Okay, nice.